Okay, so our objective today is to learn how to change an equation, or change, let's not say and, let's say change equations, to use elimination to solve a system. So basically you're going to be given equations where you can't just eliminate, because if you added the two equations together you wouldn't get rid of one of the variables. So you're going to have to do something to change the values so that you could just add together and get rid of a variable and solve. So what we're going to do is we're going to go through a couple of examples, talk about some choices, and then go ahead and write down just a couple of key ideas about what's going to help you in your homework tonight. So directions are going to say solve. So we've got 7x minus 5y is equal to 76. And then we've got 4x plus y equals 55. So in other words, at this point, if you look, your x's don't have the same coefficient with opposite signs, your y's don't have the same coefficient with opposite signs, so we're going to somehow have to change one or both equations. So either we get the x's to match or we get the y's to match. So a couple things I'm going to look for is, do I have a variable with opposite signs? And if you look at your y's, you have a positive y and a negative 5 for your coefficients, positive 1. And then could I just get away with multiplying one of the equations by something in order to get the coefficients to match? And the answer is absolutely on this one. So if you look, if I multiply the bottom equation by 5, every term by 5, that equation becomes 20x plus 5y equals 275. Now if I bring back down that original top equation, I have 7x minus 5y equals 76. And if I now add my equations together, the 5y's are going to eliminate. So that leaves me with 27x equals 351. Divide both sides by 27, and I get x equals 13. Now the reason why I knew that is I've done that problem 3 times today, so I have memorized that answer. That's only half of my answer. So the x is 13. So I'm going to take this value and I'm going to substitute it back into either original equation to solve for y. Probably the simpler of the two would be the second one, because the variable that I want to get alone has no coefficient, so that's pretty cool. So it's going to require fewer steps to get to the answer. So I just substitute in 13 for x and then solve it out. So I get 52 plus y equals 55. Subtract 52 from both sides, and I get y equals 3. So it looks like the solution to the system, the point where these two lines would intersect, would be at 13.3. So what I want to do is a check and see if it makes sense. So is 7 times 13 minus 5 times 3 equal to 76? So let's see, that gives me 91 minus 15 equals 76. Ooh, that was not very good. 76, there we go. And if I subtract here, I get 11 take away 5 is 6, 8 take away 1 is 7. And so what it tells me is it satisfies the top equation. So let me try the second equation. That one is 4 times 13, that plus 3 is that answer 55. So I get 52 plus 3 equals 55. And I get 55 equals 55. So that satisfied the second equation. So that just verifies that 13.3 is the correct answer. So this problem was really cool. Now I know some of you might say, well, couldn't I just subtract 4x from both sides in the second equation and then use substitution? And the answer is no. And the reason why, we're using the technique of elimination, and that's not the elimination that we were looking for. Elimination means you're going to add your equations together to eliminate one of the variables. So in this particular situation, I had to multiply one equation by one value to get a match on the coefficients with the same number but opposite signs. All right, let me talk to you about a second problem. And this problem has a lot of different ways to solve it, and we're going to explore all of those different ways, just so you can see how things get done. So, second problem, we've got 5b plus 10c equals 15, and we've got 3b minus 2c equals negative 7. So this problem is different in that I see a coefficient in front of every single variable. So it wasn't as simple as the last one where I had a coefficient of 1 and I could multiply be easy. So let's see if there's maybe a relationship between the coefficients of one variable. And so if you look at C, what you would notice is that 10 and 2 have something in common. They both are divisible by 2. So what I could do is multiply the bottom equation by 5. Notice that the signs are already different, so that's a good thing. So multiply everything by 5, and that equation becomes 15b minus 10c equals negative 35. Now bring that other equation back, and we have the first one, 5b plus 10c. And notice your c's have exactly the same coefficient, but opposite operations. So now what we can do is add to eliminate, and you're going to eliminate the c's this time. So this gives you 20b equals negative 20, divide by 20, and we get b equals negative 1. So let's see, b and c, alphabetically b comes first, so it's taking the x spot. So now I'm going to plug this back into either original equation, and I'm going to be solving for the c. And it really doesn't matter which equation I plug into. I'm going to plug it into the second one because the numbers are smaller. So that's my only reasoning for it. So I have 3 times negative 1 minus 2c equals negative 7. So I get negative 3 minus 2c equals negative 7. I'm going to add 3 to both sides to get the negative 2c alone. And I get negative 2c equals negative 4. Divide both sides by negative 2, and I get c equals 2. So it looks like my solution is going to be negative 1, 2. So I'm going to do my check and see if it satisfies both. So I have 5 times the quantity, negative 1, plus 10 times the quantity, 2, and we want to figure out if that equals 15. So I have negative 5 plus 20 equals 15. And that's going to give me 15 equals 15. So this actually satisfies the first equation. And then I've got 3 times negative 1 minus 2 times 2. And does that equal negative 7? So I have negative 3 take away 4, and that equals negative 7 is equal to negative 7. So it satisfies both equations, and that's my answer. Okay? All right, so let's bring them back again. 5b plus 10c equals 15, and 3b minus 2c is equal to negative 7. Now, I don't know about you, but I noticed something interesting about the top equation. Every single one of those numbers is divisible by 5. So I was just kind of curious what would happen if I divided everything by 5 in the top equation. That would give me b plus 2c, equals 3. So notice that sometimes in order to get my equations to have a match, I might be able to use division. Now I would only use division if I got an equation that did not contain fractions. If division is going to give me fractions, that is not a good strategy to use. So that's another way that I could alter things. All right, let's do one more. Let's see if I can fit it on here. This one I'm going to tell you, you have to do something specific. So we have 5b plus 10c equals 15, and 3b minus 2c equals negative 7. What if I told you you have no choice but to get rid of the b's? That's your only option. I will not let you get rid of the c's. You may not eliminate the c's. What could you do to get the coefficients to match and have opposite signs? And what you could say is, well, if I wanted to get rid of the b's, and one has a coefficient of 5 and the other has a coefficient of 3, what if I made them be the least common, like denominator, least common multiple? So let's see, 5 and 3, that would be 15. So what do I need to multiply by 5 to get to 15? I need to multiply everything by 3. Now, not only am I going to need to multiply by a value, I also need to multiply by a sign in this case, because right now the b's have the same sign of both positive. So 3 would have to get multiplied by a negative 5 to achieve the difference. So let's double check and see if that actually works out. So I get 15b plus 30c equals 45. And I get negative 15b, where, there we go, plus 10c equals 35. Okay? In both of these cases, I would end up getting exactly the same ordered pair. And I can, again, we could show real quickly on this one how that would work out. When you added here, you would eliminate the b's. That would give you 40c equals 80, and you divide by 40. Sorry, I'm doing my math backwards. And I get c equals 2, which is exactly what we had the first time we went through this. On that other case where I divided by 5, let's do this over here. So if I add these up, I get 4b. The c's would eliminate, equals negative 4. Divide by 4. And I get b equals negative 1, which again is what I got. So notice all these different things that I could try in order to get my coefficients for one variable to match with opposite signs. So let's just write up a couple things that we notice. And I'm going to write this in very general terms for the process that I'm going to use. Is I'm going to multiply one or both equations by a factor or factors. So I'm going to use that parentheses s. Means if I multiply by one factor, or I have to multiply both equations, it may be different factors. Multiply one or both equations by a factor or factors so that the coefficients for one variable are the same number but have opposite signs. Every single situation that we did, even when I had 3 alternatives for the second problem, I did the same thing. I multiplied one or both equations by a factor or factors so that the coefficients for one variable ended up being the same number but with opposite signs. And once you do that, you're going to add the equations to eliminate one variable. Now, I'm not going to write the rest of this because you've written it at least 2 times now. Once you do that, you solve for that remaining variable. Then you take that variable you just solved for, substitute it back into either original equation, and solve for the second variable. And the last and key most thing after you get your ordered pair answer is to check it with both equations to make sure it makes them both true. All right, good luck with your homework tonight.